Uh, Thank you all for being here. We are at Government Science and Technical College, Gariki, Abuja. Today, we're going to take our second feature on Understanding PKI. With us today is our guest, Mr. Thomas Gustafson. Thomas, we're going to talk to you and hear more from you. But before we go on, I had a presentation prepared that I want to share with everybody, just a foundational knowledge so that people can understand PKI and all of that. So let me share my screen. So here we are. We've had this lesson before. So there we gave a brief understanding of what cryptography is. But I'm going to go back and let's discuss all of it again. So what is PKI? PKI means public key infrastructure. It is a system for the creation, storage, and distribution of digital certificates, which are used to verify that a particular public key belongs to a certain entity. What that simply means is that there's a need for us to connect it and talk to each other, okay? And for one person to talk to the next person, I need to prove that, especially in separate geographical locations, I need to prove that I am the person that is actually talking to you, and there's nobody in the middle talking or pretending to be me. So that's why you require PKI or a certificate. Is that okay? Now, what is the foundation of PKI? The foundation of PKI is actually cryptography. Cryptography is the science of converting clear text to ciphertext using algorithms and keys. So, for example, if I have the word cybersecurity and I pass it through a crypto system, okay, I would be able to come out with something that looks like something gibberish, as in something that doesn't make sense. Okay, take for example, you want to talk to your bank. You're going online to talk to your bank, and you need to make sure that that server you're talking to is actually your bank server and not someone in the middle. Okay, your bank will issue a certificate which your system will confirm. Okay, and then you can start conversing. But after doing that, he does what you call encryption. It encrypts the information that you share using another algorithm. Okay, and today we're going to see what that algorithm is. So there's another definition of cryptography here. Cryptography is the study of secure communication, like I told you, banks communicating with each other, that allows only the sender or the intended recipient of a message to view its contents. So if I am not the one that is supposed to get a message, even if I intercept that message in any way, that message, I will not be able to read it or to access it. Okay, that's what cryptography puts in place. Okay, now there are three types of cryptographic techniques. The first one is symmetric or secret key cryptography. Then the second one we're going to talk about is hash functions. And the third one we're talking about is asymmetric or public key cryptography. I'm going to show you a little of what it looks like. So for symmetric or secret key cryptography, you use a single key. What that means is that I will use a single key to encrypt a message. Then I and the person that I'm sending the message to will share that key. And the person will use that same key to decrypt a message. If you look at what we have here, you see that there's a file that I created. I called it my test. And inside I wrote a lot of things. Okay? Now, I now ran it through a cryptographic algorithm. Okay? using AES. AES is a symmetric key algorithm. So it uses the same key to encrypt and decrypt something. So I ran it through that. And as you can see, it came out with all of this. This is the file after I've encrypted it. You see all of this information here that I wrote. If you look at it, you cannot make any sense out of it here. Can everyone see my mouse? You can see my mouse, right? So you can see that you won't be able to make any sense out of it. So it's only the person that is receiving it that has the same key that will be able to decrypt it. Okay, good. So this is symmetric or secret key encryption or cryptography. So hash functions. Now here in hashing algorithms, you change any size of text into a fixed length text. Okay, and it creates a hash of that text, and that information you can use it to check the integrity of the information, whether it has been altered or not. Now, as you can see, I had the same information here. Look at the information very well. Can everyone see what I have here? Now, after the word asymmetric key public key cryptography, can you see the semicolon at the end? You can see the semicolon. Now, I ran it through this hashing algorithm. This hashing algorithm is secure hashing algorithm, SHA, with a key of 256. I ran it through it and it came out with this hash. Can you see it? SHA, notes, and all of this. And the last four letters is 8995. Can you see that? Good. Now, look at what I did. Under here, look at number 3, asymmetric public key cryptography. Can you see that? Now, I removed the semicolon. I hashed it again. Can you see that? I hashed it through using OpenSSL, DGST, SHA-256. Now, see the output. Can you see the output? Can you see the output? You see that it is very different from this one. Here, where you have 8995, here you have D85B. Can you see that? I just removed the semicolon. But just because I did that, see the difference in the output. So that is what hashing is used for. Hashing is used to check the integrity, and sometimes for other higher things that Thomas is going to talk to us about. Let me go to the third form of cryptography here. Now, this third part is the public key cryptography, or the asymmetric key crypto systems. So now this is asymmetric. In symmetric, you use one key is used to encrypt and decrypt. Now there's a problem with that. If I want to talk to somebody in the US, how do I send the key from here to the US? And how do I know that the person that received it is actually the person that is supposed to get it? Okay, so that is key management is a problem. But we needed to go beyond that level. Like for your internet, you talk to different people, like we're having this webinar now, people are coming in. If we need to ensure that the communication between us is secure, it will take a lot of work. Sharing keys, exchanging, and all of that. So that was why scientists came up with a different form of cryptography that uses 2 keys. Now, the 2 keys, one is a public and one is a private key. The public key is accessible to anyone. The private key is kept only to the owner, with the owner of the key. Okay, so every individual has 2 keys, one public and one private. Now, if you as an outsider want to send me a message, you will encrypt it with my public key. Okay, when you encrypt it with my public key, I am the only one that can decrypt it. No other person can. Okay, now, if I want to send you a message, I will encrypt it with my private key. So when you decrypt it with my public key, you are sure that that message actually came from me. That is the technology behind the communications that we do on the internet. Okay, now if you look here, you can see that I created a private key. Now, using this command, OpenSSL generate RSA, it produces two things actually. It produces the public and the private key. Okay, but the public key needs to be signed by verified certificate authority. And that verified certificate authority is, if you go to your browser, you will see VeriSign. Have you ever noticed it? Like if you open a browser, you will see VeriSign or a padlock. And when you look at the padlock, you will see the people that signed the certificate. You've not bothered to look at it. Now you have to go and try, check it from now on. Who signs a certificate, okay? So what I did here was, after creating the private key, I now created what you call a certificate signing request. Okay, now this certificate signing request, you can see that I entered my name, I entered my location, I entered my unit and all of that. So with that, those are the informations that identify me. So when I get that certificate signing request, I send it to VeriSign or any certificate signing authority. And that certificate signing authority will sign it to tell everybody that this certificate actually, this public key actually is Ame Udobon's. Do we understand that? Okay, am I making sense? So now I want Thomas to come in now.
Hi, I can hear you well. It's cracking sometimes, but mostly good.
Okay, Thomas, before we go into talking about public, private keys and everything about that, I want to say thank you once again for letting us talk to you. But these are young men. I believe looking at them, you feel this sense of I was once like this. I want you to tell us about yourself.
From Sweden, where spring is just starting, and I'm a developer at heart, so to say, a programmer and a PKI geek. So I've been working with computers since I was a little boy. And I started working with PKI in 1994, actually. I was doing my math thesis in computer or electrical engineering, actually, but with computer.
Okay.
So I started working with PKI in 1994, actually at the university when the first PKI systems were developed in the 90s. And then I moved on to work with PKI as a consultant, as a developer, and has been doing that since. And in 2001, and based on our open source project, we started a company, me and my son colleague, in 2002. And that's what I've been doing since then. So developing PKI, working with PKI projects all around the world, both in Europe, United States, Africa, and Asia.
Okay.
Anything more you want to know?
Thomas, how were you able to convert your ideas? Because I understand that your EJBCA was your thesis in the university. How were you able to convert it into a business?
Yeah, that is a very good question. So it took quite some time. So it was a lot was not, well, PKI was rather early, but we decided, or the company I was working for then went bankrupt because there was the big IT crash here in Europe in 2001 or 2002. So the company went under, and then we could actually get some, say, unemployment money from the government to start new business. So we started a business around EJBCA to work with that. And EJBCA rather quickly got some, since it was open source, it quickly got some users around the world. So some of the first users were in Sweden, well, since we were here, but then quickly came some, we had some users in China, some found EJBCA because it's open source and available to everyone. And then I was very good at providing help for anyone who needed assistance with EJBCA. And then we could start to sell services or consultancy around the EJBCA. There was quickly companies starting to use EJBCA who needed some new functionality, for example, and then they could hire us to develop the functionality. And they also needed support. So if they use it and something is not working, they could pay us to help them. And slowly, this grew. In the beginning, we were only 4 people working, having some government, say, unemployment money to be able to work. But after a couple of years, we and slowly and consistency, I would consist by hard work, always developing, always helping everyone who needed help with EJBCA. We were able to develop the business with more services, and in the end, there are now hundreds or thousands of companies using EJBCA for their PKI, and you only need a portion of those that actually are paying customers for us that now buys services and the products. Now we have expanded with lots of other products, such as a hardware appliance, the cloud products, but it's the same foundation, the same software in the bottom, but you can sell it in different ways, for example, as a cloud service.
So, how would you encourage young people in science?
Slowly, year after year, building up a little more.
Thank you, Thomas. How would you encourage young people in science, technology, engineering, and mathematics to create wealth?
I think, at least for me, it always have started from an interest, so to say. If you have a passion to do something, and to also, of course, the passion is not only for myself, but I want to help others to use things, to use PKI to enable them to communicate securely. And if you develop it consistently, and you cannot be in a rush, I think. You have to start, and aim to do something good, something that you're interested in, and do it for a long term, then you can grow something very good out of it.
Okay, so let's go back to EJBCA now. So what is EJBCA and how can it be used by a small business?
EJBCA is the software for a certification authority. As you just mentioned, your example was that you create a CSR with a public key and then you send it to a certification authority such as DigiCert or something like that, and you get a certificate back. So the software that these online CAs operate is they work on is EJBCA. Many of them actually use EJBCA as their software. So in your organization, when you need certificates, so you quickly need certificates if you want to do secure communication. So in your company, you can use EJBCA to create those certificates and manage them.
Okay.
And you can use it, of course, as an open source. So you can start by free, and then you can build it into, if you, for example, many other products, if you develop a service or even a device, then this device or service needs security, and then you can use EJBCA as a security infrastructure for this. So of course, EJBCA is not a goal in itself. It's only a security infrastructure. But when you, maybe if you have a web shop or you develop a smartphone, then it needs a lot of security in these things that you develop, and EJBCA helps you to
Okay, sorry, we lost you there for a minute. We're having a very unstable network around here. Please bear with us. Okay, now you mentioned something about mobile devices. Okay, in what area of technology can I apply PKI? Especially in this era of Internet of Things. And grid systems, large energy infrastructure controlled by computers. So how can PKI be used in such a case?
Yes, so I mean, you are all already using PKI. Even if you don't see it, it's there when you uses PKI in the background for secure communication. Or when you travel with a passport, there is PKI in behind passports as well for digital signatures, as you also mentioned. So there are some obvious areas for PKI are like electronic identity, which is traditionally, at least here, you had a plastic ID card, maybe with a chip on it, but today you want to do it in the mobile. So you have a mobile ID, so you can log into your bank, and it uses PKI to both identify the bank, so you know you're connecting to the right bank, but also authenticating you, so that when you log into the bank, they know it's you. And some other use cases are, for example, in manufacturing. Today, when you manufacture things in a factory that are smart metering, then these devices needs to have security, and we call it security from cradle to grave. So already in the factory, many manufacturers put certificates in the devices. So when you install the electricity meter in someone's home, it can be connected to the power grid securely, so that, say, no impersonator can install a false electricity meter there. So that's are some very common use cases here. There are also some more, you can say, exotic use cases. For example, drones. If you have drones that which today can be used for everything from agricultural to monitoring in airports, etc. You also want to control where and how these drones can fly. So there are some use cases where that the drone has an identity before it can fly.
Okay, so I want to ask you this question. Now, you mentioned using PKI to authenticate drones. Okay, how are we sure a PKI cannot be, I mean, a group of drones cannot be recruited by an attacker and used for the wrong purpose?
That's, of course, a very complicated, complex issue. But there are some, at least standardization work going on, that the drone manufacturers will have to, some are suggesting now that drone manufacturers have to put in the digital identity. Manufactured are not allowed to fly over airports, for example, so they cannot be used to disturb airport traffic. And also that say law enforcement, like police, can, if the drones are used like that, they can override and send the drones to land.
Okay.
So this is not the reality today, but there are some work going on to try to make this happen.
Okay, now in a situation where you have a hospital that has devices that are life-saving devices, and now we have grids, like power grids, that provide utility services for a community or a country. Now, from research, we realized that machines now control machines. How can one machine authenticate to another using PKI?
So this is also very common. Medical devices is actually a very large area for PKI, where, of course, in this case, both machines have certificates. So there's usually one machine that wants to control another machine, and then they must use certificates and private keys, as you were talking about, to authenticate to each other. So the device being controlled only allows a trusted device to control it, and the device that will control another device also can be ensured that it is the right, if it has to send data and commands to a device, it knows that it sends it to the correct device, because every device have an identity. Or put on, afterwards installed in the hospital themselves.
Okay, do I know if you have a question to ask, please? If you do, please come forward. Okay, thank you. You're coming, right? I was expecting you to ask some questions, at least to ask him that you have an idea and you want it Or you want him to guide you or mentor you or something?
Yeah, I can say, since I like open source, for example, so this is a very great tool to create things from scratch.
Okay.
When I started EJBCA, could only do it because there were already other tools available. So I, for example, used the Bouncy Castle cryptographic library, which implements everything you have shown here. Is implemented in this library called Bouncy Castle, which is from Australia, and it's also for free, of course, and open source. So that was I could not have started EJBCA without Bouncy Castle already being in place. So you have a lot of different components that you can work with, and you know, start your ideas. So you don't have to do everything. You don't have to be a cryptographer in order to use PKI, but you can use the available libraries, which are much higher level. So you don't have to understand the RSA algorithm or exactly how to create the hash function, but tools like OpenSSL or Bouncy Castle are very quickly get a grip on how to use them and make your ideas come true.
Okay, so Thomas, I didn't know I was going to ask you this, but I just thought about it. Do you have a system where young people like this can be interns or work with you remotely and all of that?
Good question. So not a established system, if you say. We do at our company, we do a lot of internships for, of course, the local students who come and work for us. We haven't done that remotely yet. I have helped people remote. People use my software and they ask me questions and I help them with anything they ask to both they teach them how to use it and help them if there are problems using it, etc. So this I have done many times with many people.
Okay, tell us about Prime Key and the PKI services you provide.
Sorry, it was cracking the sound a little bit. Can you repeat the question?
Yes, I said tell us about your company, Prime Key, and the PKI services you provide.
Okay. Yeah, so we have some, we are very focused on PKI and digital signature. And we want to be the best on PKI and digital signatures. So what we have is uh, basically two products. One is called EJBCA, which is both available as open source. You can download it from egbca.org. But we also have an enterprise version, which we sell for money to large companies like Siemens or Ericsson or Air France, etc. And we have another product called Sign Server, which is for digital signatures. And it's the same. It's also available as open source on signserver.org. And we have an enterprise version, which we then sell to our customers. And we package it so in different formats. So our customers can get the software they can get it as a hardware appliance, which is a hardware server database and such. But it's very easy to get started, and also as a cloud product, so you can buy it at in Amazon or Microsoft Azure, when start it, and you pay for by the hour as is normal in those circumstances. And finally, we have a PKI as a service, so a company can pay us to operate their whole PKI, which is then all the computers, hardware security modules, the EJBCA, if you want, and such. So those are the products and services that we have built on top, you could say, of the open source products.
Okay, let me ask you this trick question. Where do you see PKI in 20 years from now?
That's a very but now I've been doing PKI for 20 years already. And right now, or for the last, say, 5 years, the usage of PKI has grown tremendously. So much more has happened in the last 3 years than was happening in 15 years before that. So I see at least the coming 5 to 10 years will be increased demand for security, where PKI is the best or de facto standard technology which is out there. So of course it will evolve. There are new algorithms, new cryptography algorithms coming out all the time, and some new standards. So it will technically, it will develop over the years. So maybe in 10 years there will be look a little bit differently, say technically. A certificate may have new formats, there will be new algorithms, but the underlying need for securing communication and the security services that PKI enables, which are authentication, integrity, and confidentiality. So these are will stay for the coming 10 years, for sure.
Okay, now let me talk about the other side of cryptography, ransomware and quantum computer threats. How do we see that in future?
That's very nice. I was actually thinking about quantum computers now when I was preparing a little bit, thinking before this session. And I mean, say malware and ransomware and such, those are, there's always, every technology can be used for good and for evil, of course. In the case of then it's used for bad. But then we have to be better at, well, we use, of course, PKI or cryptography as defense against the bad actors and the criminals. So it's also, even though the criminals use cryptography, the best defense against the criminals are cryptography. And of course, it's a peaceful defense as well, just preventing anyone from getting access to your system. The when you talked about how we see it in 20 years, the quantum computer threat is very much on the horizon there. So there is the threat is that if large-scale quantum computers are developed, or are we are able to develop such, then they can break the cryptography that we use today. But the research community today is very active in developing new algorithms, which is called post-quantum cryptography. So post-quantum cryptography is secure against quantum computer threats. So these algorithms will be, say, complete and standardized within a couple of years. So the goal is to have new quantum safe algorithms deployed and ready before quantum computers actually pose a threat.
Okay,
So
thank
it's
you.
a lot of development in that specific area right now. Very interesting area.
Okay, and
a good thing with cryptography is that it's always open. Standards are open and usually freely available. And the same with the cryptographic libraries. For example, the Bouncy Castle, as I mentioned, also have implementations of post-quantum cryptography algorithms. So you can look into it and try it out and implement, learn from it. It's a very interesting field.
okay,
Not easy, but interesting.
okay, thank you. Will you be able to show us how we can use EJBCA to create a certificate signing request and sign it, upload it to a web browser, revoke, and all of that?
Yes, absolutely.
Okay, thank you.
So can you see my screen now?
Yes.
Okay, so this is EJBCA, which I have installed locally on my machine. So there are, I have lots of test certification authorities here that I can create certificates. So in EJBCA, we call that certificate profiles. So I have client certificates, I have SSL certificates or TLS certificates, SSH certificates even. So I have, this is my say test configuration. So there's lots of test or different types of certificates. So let me add actually here. Let me show this. So there are many different ways that you can request a certificate. So one type is for, as you mentioned, you can in a web browser, you can upload a CSR and you can download certificate or a key store. Another common workflow is that you have to have an administrator that approves your request. So then you upload a CSR again, but another administrator has to approve the request. Talked about here. Then you often use some APIs instead to automate the process, to make everything automated. So I can show different methods. So I can start with the first one. So this is what is called the RA interface in EJBCA, or for which stands for Registration Authority. So here I can request a new certificate, say make a new request. And then I can select, in this case, I will make a user certificate, and I will select a certificate subtype, and I will issue this from one of my certification authorities. And if I want to upload the CSR, I say that I provide the CSR, and then I get this box. And I have a CSR here, which is, I created it exactly like you did with OpenSSL and rec. So it's just a it has an RSA public key of size 2048 bits. And then there are many possible fields that you can enter or that you can request. So common name is a normal field for the name, and this is me, so I say, okay, I'm Thomas. But you can also request, say, for DNS names, that's a server name, and IP addresses and such. But once you have filled in all the fields, I can simply download the certificate file. So now it's actually issued from my CA, and I can download it. So I will save it. And then I can look at it also with OpenSSL. Prime key, etc. And it has the public key, 2048 bits, and some other information which is specific for the certificate profile that I was using. Then I can show you another way. So now I'm logged in as another user. Say I'm a normal server administrator of a web server. And then I can make a similar request. But now I will use a profile that requires an approval. So here I do the same thing. Upload my CSR. And I don't have to enter any fields. Here I enter a username and actually give a password here, which I will use later on when I retrieve my certificate. So now a request has been sent to the administrator, and I can see I have a request ID, which I can check. So it says it's waiting for approval. And then in my other browser, here I am the administrator who is allowed to approve. And then I can manage requests. And here I see, okay, this is the request that came in. And I can look at it and see what was requested. Let's see that everything looks okay. And then I say, approve this request. And then it says you have approved this request. And then if I go back to my other web browser and check again, then it's approved. Then I can download it. And now I have to use the password I used when I requested a certificate. And then it's downloaded as well. So that is two different ways to use the web browser. So here I can use a standard protocol called EST, which is RFC 7030, an open standard which anyone can download and read. So here I will make a command which is using curve, which you have on your Linux machine built in. And I just make the command and the certificate is ready already. It has been issued. So this is an automated process which is suitable for machines because they don't use web browsers. And as an administrator, I can go in and search for my machine, so to say. So now I have done this before, of course. So I have this was the like we call it end entity. And here we see that I have issued some certificates to test before, and this was a certificate that we just issued, and I can look at that. And here I can also, since I'm here in the web browser, I'm logged in as an administrator. Here I can revoke this certificate. So if it was, for example, an electricity meter, but it has been stolen, then I can say, okay, it was key compromise, which means that someone has stolen the private key, and I say revoke it. And then this electricity meter is not allowed to communicate on the network anymore. So I think, so that was a short demo of how PKI is used in some use cases.
I know it looks a bit complicated, but it's something that once you work on it over time, you get used to it. It becomes a routine, okay? So it's not really as difficult as you think, okay? And like you said, they have a free copy that you can download and play with. You know, you can work on it. I have that copy. I think I downloaded it a long time ago. So in case you're interested in working with EJBCA, and it's open source, so you can also create products on top of it. In case you have an idea, you know how busy you are, and sincerely we're humbled to have you come talk to us today. We hope you'll be willing to join us again for another webinar. Thank you
Absolutely.
so much.
It was a pleasure. Thank you for inviting me.
Thank you. So, well, can I say everybody? Ajayi, your video is not up. Okay, I can see you now. So I want to say thank you for joining us. I hope you'll be here again next time. Thank you. Bye-bye.
Thank you. Bye.